I'm going to present a paper called ExaAEC, a new multi-label emotion classification corpus in Arabic tweets. I will first talk about the emotion and emotion detection, emotion models and data sets and studies done to emotion detection, and the way that the corpus was constructed, the experiments to model the dataset, and the results of the study. Nowadays, the usage of social media tools by individuals to share their emotion and opinions in the form of short text messages is increasing. Emotion has a significant role in people's interaction. Detecting emotion, especially from text in social media, has become a challenging problem in NLP. Although people can often tell whether the author of a text is angry or pleased, detecting emotion of some text may be struggling even by a human. This is a challenging task for computers because of the lack of the background knowledge which humans use while writing a text or tweet. Trying to model such a recognition system is a difficult task, not only because of the scarcity of some training datasets, but also because of the limited information contained in a tweet or a short text. Emotion detection is recognizing the emotion that the writer wants to express when composing the text. Because of the large number of text, manual emotion classification is inefficient, making the use of the detailed information system necessary. To do that, we need a dataset that is annotated in some basic emotions. So, definition of the human emotions based on some metrics, ranks, and dimensions in a structured way is called emotion model. The most studied categorical model of discrete emotion is the Ekman model. The Ekman model includes anger, fear, disgust, joy, sadness, and surprise as basic emotion. Another categorical model is the one by Shaver et al. That is the same as Ekman, but the love emotion is considered and the disgust class were removed. One of the famous and most studied dimensional model is the well-found psychological Plachik model. From a computational linguistic standpoint, this model has recently been applied to emotion analysis. The Plachik model consists of 8 basic emotions. The emotions are joy, trust, fear, surprise, sadness, disgust, anger, and anticipation. In this encoding, each emotion has a degree of intensity that is depicted by radial directions. Also, the similarity degree is different between emotions that are expressed by angular directions. There are also complex or composite emotions in the whole that are the mixture of the basic emotions being in the blank space of the picture. There are 8 composite emotions in the figure as demonstrated. Each basic emotion in the hill is subclass of a larger class that other subclasses are the same with a stronger or weaker intensity. For example, the trust, admiration, and acceptance are subclasses of the trust class with different strengths. It can be said that 32 emotional classes can be extracted from the Plachik hill. Here are some of the most commonly used datasets in the recent research on text emotion are mentioned. Bank is one of the famous ones, containing 110K sentences, having double annotations with valence, arousal, and dominance from the perspective of both writer and reader of the text. The ESO are having about 7,000 sentence forms responses from questionnaires on 7 emotions from 37 countries. ICCKE is another Arabic emotion dataset having about 1,300 Facebook posts. The posts are annotated in 6 classes based on the Ekman model. Another Arabic dataset having 5,600 tweets in 4 classes was provided in semi-eval for the EIOC task. The classes were anger, fear, joy, and sadness. The most studies done in the emotion detection are the lexicon based that use a lexicon and search the words in the lexicon having a rank for each word. Another approach is the machine learning based that use machine learning algorithms, and finally the deep learning algorithms to classify the emotions. But the way we have constructed the corpus, the taggers should annotate tweets into or one emotion most expressed in the text. The neutral tag is annotated when none of the other classes can be annotated for a tweet explicitly. The emotion of the whole tweet were accomplished by 6 native Arabic speakers. Each tweet was cross-annotated by the 3 taggers to ensure the quality of tags. The final label of an entry was those labels were annotated by at least 2 taggers. In some cases that the tweets were ambiguous and annotations have no intersections in 3 tagger annotation sets, the 4th tagger has evaluated and re-annotated the tweet's emotions. The kappa-pairwise agreement is calculated to measure the inter-annotator agreement, and the results show that the value of the kappa were 79.1 for this data set. We have about 20 hundreds tweets annotated in Arabic emotion in this study that have 10 classes. The number of single and multi-emotion tweets are about 13,000 and 6,000 respectively. The experiments were as the normalization, vectorization, and the model creation. That in the normalization, some basic tricks pre-processing operations were done, and after that the vectorization and model using deep learning having 3 LSTM layers. The result of the study are depicted in this table, and can be seen that for example the anger class has the lowest FEC measure, and it's maybe because of the nearity and similarity between the anger and disgust classes. If we want to conclude, we can say that one of the issues with emotion detection in Arabic tweets is the scarcity of datasets. In this study, a new corpus of Arabic emotion detection tweets is presented. The tweets are annotated in a model inspired from Plotchik model. Totally 10 emotion classes are considered, including Plotchik classes plus 2 more class, namely love and neutral. In order to increase the COPPA papers agreements, the final tag of tweets were considered the class annotated by at least 2 taggers. Finally, an Elmo vectorizer followed by an string is created for classification of the proposed corpus. It's hoped that this work could help the task of low resource languages in NLP. Thank you very much for your attention to this presentation, and you can ask your questions if you have.